we'll take a look at some gas law processes. Now I've got this container right here, and it's a steel container, and its volume is not going to change very much as we heat it and cool it. So we can assume that this is basically a constant volume, okay? So we've got a constant volume. Inside here is air, and the air is hooked up to this gauge, which allows us to measure pressure. And right now, it's measuring 15, and that's 15 pounds per square inch, which is approximately atmospheric pressure. Now, if I take this container and I dunk it in this bowl is full of liquid nitrogen. We can tell that because it's very, very cold, and if I get this silk flower cold, it makes a lot of little droplets of water come off here. It's condensing water out of the air to make a little fog. So very, very cold. If I take this container and make it very, very cold, how will that change the pressure? Now think about what we talked about in the last segment. Think about what the molecules are doing. I'm going to get them very, very cold. How will the pressure change? We'll give you some choices. Well, if I get this container cold, the air molecules inside here get cold. They're not moving as quickly. They're not hitting the walls of the container as hard. And so as a consequence, what happens to the pressure is this. The pressure will decrease. So you saw what happened. The molecules aren't moving as fast. They're not hitting the walls of the container as often, and so the pressure decreases. And we have an equation that shows this for a constant volume process. And this was a constant volume process because the container that we have has a constant volume. And so the gas is inside a rigid cylinder, okay? And that's an example of a constant volume process. Now, that's very, very cold gas inside there. What I'm going to do next is this. I'm going to take this cylinder and I'm going to connect it to this gas vessel that we have. So the gas vessel is very, very cold, and I'm going to connect it to this cylinder right here. And then what will happen is this. Gas can go back and forth from one to the other. Now look at this piston right here. This piston is free to move, and on this side of the piston is atmospheric pressure. And so inside, the pressure has to be the same as the external pressure because this piston is free to move. And so if I take this container and let it warm up, it'll warm up. The temperature will change, but the pressure won't because the pressure is fixed by the atmospheric pressure, which is on the other side. So if I take this container out of the liquid nitrogen and I allow it to warm up, actually I'm going to help this along by taking this container and putting it on top of a warm cup of coffee, and that's going to help to warm this up a little bit. And as the gas inside there warms up, the pressure can't change. The pressure can't change because of the cylinder is connected to it. And so as a consequence, what happens is this. The cylinder moves outward and the volume increases. So we can see at a constant pressure, as the temperature goes up, the volume increases as well. And it turns out that a graphical representation of these gas law processes is a nice way to kind of like get a handle on what's happening. Well, we've seen examples of constant volume processes and constant pressure processes. We have one more example to look at, and that's an example at a constant temperature. And constant temperature is easy to arrange. Constant temperature just means you do something at room temperature and you give things time to stay at or come to room temperature. And what we're going to do is this. I have a container, and inside the container, I'm going to put some peeps. And these are ghost peeps. And peeps are marshmallow candies, but they're made mostly of air, because marshmallows are made of two things, sugar and air, plus some flavoring and such. But mostly they're made of two things, sugar and air. So I have peeps inside the container. And it turns out the volume of a peep depends upon pressure, just as the volume of a container of gas does. We can think of these as little samples of gas. There's a certain number of molecules of gas inside each one of these peeps, and it doesn't change, but they can expand and they can contract. So what I'm going to do is this. This container has a little plunger. When I put this on top and I pull up on it, it pulls air out of the container. What that'll do is it'll decrease the pressure inside the container. But I'm going to do that slowly enough that everything stays at room temperature. So the temperature will be constant at room temperature. The pressure inside the container will decrease, and so therefore the pressure of the gas inside the peeps will decrease. And if the pressure decreases at a constant temperature, what happens to the volume? What is going to happen to the peeps when I pump the air out of the container? We'll give you some choices. And now, let's try it and see what happens. If I take this container and I pull air out of it, the pressure inside the container decreases, and so the volume of the peeps increases. They noticeably swell. They noticeably swell. Oh, yeah. And they're starting to look distinctly uncomfortable inside their little home. But that's okay. We'll pump it a few more times. And there we go. And it's not that I'm putting more gas inside the peeps. They're sealed. They're a sealed system. And we can tell that because if I let gas back into the container, here's what happens. The peeps resume their original shape, their original size. All that's happening is the gas inside them is expanding and contracting. And so peeps follow the ideal gas law. This is an example of a constant temperature process because the whole thing happens at room temperature, and there's an inverse relationship between pressure and volume. When pressure goes down, volume goes up. When pressure goes up, volume goes down. That's the last of the gas law processes that we'll look at in significant quantitative detail in the chapter. So we've seen three different examples of gas law processes. We've seen something at a constant volume. We've seen something at a constant pressure when I had the movable piston. And we've seen something at a constant temperature that I let work at room temperature. These are the three main examples of gas law processes, which we'll see in the chapter. But now we want to come back and think about energy again. And we want to think about the thermal properties of matter and think about changes when heat comes into things or goes out of things. That's a piece we'll look at in the next segment.